In this video, we're going to cover how to graph different functions in Vertex form. The main focus is going to be on quadratics, aka parabolas, but we're also going to cover absolute value, square roots, and exponential functions as well. The first concept to understand is what the values tell you about the graph. So we're going to interpret the equation, this one right here in fact, for every problem that we see today, and we're going to have to remember the placement of each value and what that means to the graph and how it changes the graph. So the a value, for example, that's going to tell you whether there's a vertical shrink or stretch. To describe a vertical stretch, that would be making the graph taller or more narrow, skinnier, like this. Now, that happens when a is greater than 1. So if greater than 1, if the a value is greater than 1, you have a vertical stretch. If a is between 0 and 1, in other words, if it's a fraction or if it's a decimal, you have a shrink. And a vertical shrink is going to make the graph look wider, like that. So another important detail that the a value can tell you is if there's a reflection over the x-axis. If a is a negative number, you have to reflect the parabola, or whatever the function is, over the x-axis. So it would be a frowny face, right? That's pretty easy to remember. The negative sign flips it upside down into a frown. Okay, moving on to letter B. Now, letter B isn't often used in a lot of curriculum, but I want to go over that just in case it's something that you have to go over and something that you are expected to know in your class. So the B value works very similarly as the A value. That's going to be the horizontal shrink and stretch. Instead of it being a horizontal stretch, it's going to be a horizontal shrink. So we're accomplishing the same exact change. Remember, I described if A is greater than 1, then the parabola gets skinnier, right? More narrow. Well, if B is greater than 1, it's also going to get skinnier. So the words are different. I said the word shrink for the horizontal change, but it's the same accomplishment. Now, if B is between 0 and 1, that's going to be a stretch, making the parabola wide. Or the graph, of course. This translates to all types of graphs. Now, if B is negative, if B is a negative number, this is a little bit different. We're going to reflect over the y-axis. For a parabola, that doesn't make any difference at all. Let's say this is my y-axis right here. If I were to reflect this over each other, it doesn't make any difference over that y-axis because it is symmetrical about the y-axis. So B relatively isn't covered in a lot of schooling, but I want to go over that now. For the rest of this practice video, we're not going to worry about the B value. However, at least you have those notes there to help you out. And you could apply what we learned with the other letters to the letter B, just in case that is important for you. But moving on to the letter H. H is going to be the horizontal slide, aka translation. It's most commonly known, most commonly used in school as translations. And that basically means just shifting the parabola left or right. That's all you're doing, is moving it left or right. But there's a trick about the letter H. We have a minus sign inside of our formula. So if we had f of x equals x minus 3 squared, my h value is actually a positive 3. My h value is not a negative 3. And the reason why is because if it were a negative 3, we would have a plus sign inside. So here's another example. If we have x plus 3 squared, in this example, I know that h is actually a negative 3. So how do these values apply to the graph? Well, for the h equals 3, the positive 3, that means we move to the right 3 times. And for the negative value, we move to the left 3 times. And so that would be left and right movement for any graph. Now for the k value, it's much simpler than the rest. The letter k tells us the vertical translations that occur, or the vertical slides. And this is much easier typically than the other transformations that we just covered. So, and that's because there's a plus sign here, so it's very straightforward. Let's say x minus 1 squared plus 3. I notice there's a plus 3 on the outside. That means my k value is a positive 3. There's no tricks about that. If you have a positive k value, that means you go up. So we're going to be going up 3 times in this example. And I say times or units. That's referring to the graph. That's how many tick marks you should go up. All right, let's move on to some actual practice problems. If f of x equals 3x minus 4 squared plus 2, scribe and sketch. We have a equaling 3. Since a is greater than 1, we have a vertical stretch, which means it gets a little bit skinnier. Furthermore, we do not reflect over the x-axis because a is positive, so there's no reflection, so we have a happy face. We have a happy face parabola. Now our h value is a positive 4 because there's a minus sign inside and a 4, so I know it's a positive 4, so we move right 4 times. K is a positive 2, so we move up 2 times. So if I were to sketch this as a graph, I know that my beginning point is going to be at the h comma k. H comma k. Always graph the h comma k first. That's going to be the vertex. In fact, that's why they call this a vertex formula or vertex form. We go to the right 4 times, so that's 1, 2, 3, 4, and then up twice, 1, 2. And right there is the cusp of my parabola, the vertex. I know it's facing up, and it's going to be a little bit skinny, so they just asked for a sketch, and there we go, there's a sketch. Now technically, I want to zoom in on this. You'll see on a calculator, if we were to take this parabola and zoom in, we would see that it goes up 1, 2, 3 times, and then to the left and right once. So this is what my parabola looks like if you zoom in. Okay, and I know that it's going to go up 3 times and to the left and right once because my a value is 3. So that's a little tip about drawing a more accurate parabola. Again, so since a is 3, I go up 3 times, and then I have my first 2 dots to my left and right hand side. So that's an even more accurate sketch of the parabola. If f of x equals negative x plus 1 squared, describe and sketch. Well, I know a is a negative 1. Now, since it's a 1, there is no shrink or stretch. Since a is 1, there's no shrink or stretch. Since it's a negative sign, a negative number, we reflect over the x-axis. So we have a frowny face, right? Our h value is a negative 1, so we go to the left once. And we have no k value. Notice that k is 0. There is no plus or minus any number. Don't let that throw you off. That just means the k value is 0. So we don't go up or down at all. So a quick sketch would look like this. I left once, and I could put a dot there because I don't go up or down. So there's my vertex. It's a frowny face. And that is a good sketch of my parabola. And furthermore, I know that at the negative 1 part of the y-axis is where I have my next dots. That's where my next intersection should be. It should be down 1 over 1 because a is 1. So I should just go down 1 time. Again, there's my little dot. Okay, awesome. It kind of works like slope, but that's just for the first step. All right, so the next question, we have f of x equals negative 2/3 x squared minus 1. Again, try to take your time to do these yourself before you just watch me do this. That's the best way to practice. My a value is negative 2/3. So I have a negative number, that's a reflection, frowny face. But then I also have 2/3. So 2/3 is between 0 and 1. 2/3 is greater than 0, less than 1. We have a shrink, vertical shrink, which means my parabola is going to be a little bit wider. Okay. Now for my h value, we have 0. That's right, my h is 0. So notice there's no parentheses in this problem. typically the h value is going to be what I call on the inside of the equation. And that's going to involve a square root, absolute value. Maybe it's going to be up in the exponent. In our case, we have parentheses. That's what we've been seeing, right? We've been seeing those parentheses. Well, there are no parentheses here, so my h value is 0. There's nothing inside. Nothing inside the parentheses. Now my k value, however, that's a -1, so I go down 1. To graph this, we just go down 1 here. That's my vertex. I'm also now going to use my a value to dictate the sketch. We go down twice, 1, 2, and then over 3 times. 1, 2, 3. Let's call those the 3 tick marks there. And then 1, 2, 3. It's not going to look perfectly symmetrical because I'm drawing this by hand, but there is a parabola. I really hope that tip about that a value helps you sketch your graphs more accurately. Let's move on to a different type of equation. Let's do a square root. We have 3 square roots of x plus 2 plus 1. And this is what I mean. We can see the vertex form in different types of equations. We have a square root function. The shape of a square root function with no transformations looks like this. It's a dot on the origin, a closed circle on the origin, and then a curve. And there's going to be an asymptote here that the graph doesn't cross. So that's what the square root looks like. Now we have to figure out the translations. We know that a is a +3, so that's a vertical stretch. Again, because a is greater than 1. H is a -2, so we go to the left twice. And then our k is a +1, so we go up once. So in black marker, I'm going to draw the actual graph that we have. We have left twice, 1, 2, up once, 1. So there's my closed circle. Okay, that's my beginning point. And now I also by the way have a vertical stretch of 3. So I'm gonna draw this a little bit more narrow, a little more taller. See, now it's supposed to be more of a curve. And then there's my asymptote, right? So that's a good sketch of this graph. If f of x equals negative absolute value x minus 2 plus 3, we know that a is a -1, so we reflect over the x-axis. H is a +2, move right twice, and k is a +3, so up 3 times. Now what does the absolute value graph look like? It looks like a V, kind of like a parabola, but it actually comes to a sharp point, a sharp corner. So we have 1, 2, and then up 3, 1, 2, 3. There's my vertex for the absolute value, or the cusp of my absolute value graph. And now I just face it downwards because we did reflect over the x-axis. Something like that. Now I should be following the slope of down 1 over 1, down 1 over 1. But I did this by hand, so it's not quite perfect. But each of these lines should have a slope of -1, or I'm sorry, of 1. F of x equals 7 to the x plus 1 minus 3. A little bit different here with the exponential functions. The way that the vertex form works would be like this. So the a value is the base number that has the exponent attached to it. So in this case, my a value is 7. That's definitely a vertical stretch. And then my h value is a -1. So I go to the left once. And then my k value is a -3. So I go down 3. Now what does an exponential function look like on a graph? Well, the basic form of it would look like this. Double arrows, it's similar to the square root function, but there's going to be 2 asymptotes, a horizontal and a vertical. Now basically, we could kind of treat like an imaginary point right at the origin, however. And this is where it would connect to each other. But since it's a curved line, we can't quite see that. However, this is what you're going to be moving when you're doing the translation, the transformation. So we have left once, down 3. So right here is a point that we're going to base our curve around. And then we have a stretch of 7. So this is going to be extremely narrow, right? Something like that. I do plan on making a whole video based on the exponential function and exponential practice. But this is a great review and overall practice video for vertex form and being able to identify these letters, these locations of values, and what they do to the graph. So if this helped you, please give it a like. If you need more help with other math topics, leave a comment down below requesting a topic. I'll be happy to make one just for you. And please subscribe so you can see that video when I make it for you. Thank you guys. Have a good day.